This should be a repeat of what's going to go on in the in our I've done this as part of a video already. So share screen, share computer sound. Oh, optimized for viewing a video clip. Cool. Let's see how bad that looks. So let's see over here. I really do not know. It's always really interesting to see what they're trying to show me on my teaching channel. So your latest homework involves graphs and graph IDEs. Let's see. No, not this one. Graphs. Graphs over here. So this is the last stuff. So intro to graphs, talking about graphs and stuff over here. The and over here I tell you how to set it up, how to use. So first off, creating your own graphing library is a bit difficult. So I tell you to use a library that's been created by a bunch of cool people. And then and so this video goes over how to do that.
Let's go ahead and get started with Jung, which is the library I use for doing graphs in Java. Now, if you are not going to be working in Java, I'm not really sure what kind of
but basically this will show you how to go through. I show you, here's my jar files.
Just like you would just like you would for a text file or something that you want to read.
And I show you how to paste everything into the into your folder and how to import it. And I show you and I've done it. And then I decided to, since I was already doing it, I might as well do it for Eclipse if you're using Eclipse, and also show you how to use it on NetBeans. So I highly recommend going to Jung. Going to the SourceForge website, simply because even though that's older, I mean, you can also get it from I think there's been a fork of that onto GitHub. But I haven't tried importing it yet. But getting Jung, importing it. The most important page, though, for Jung, if you want to use it, is going to documentation and then going and clicking here for the API Java doc. The manual, the tutorial over here, which shows you how to use it. So this is a nice big PDF that shows you how to use Jung. You can actually use Jung to create these graphs over here. To like literally have these, have it create pictures, which is part of the appeal of using it. This is like an industrial strength graph library, by the way. So the main thing is to look at the graph. Let's see. Look at the graph package or interface and see what methods you get from the graph. So you can add edges. You can add. You can check if you've got destination, successor, out degrees, in degrees. The out degree is going to be very important for the last problem. Or rather, the in degree. And so you've got directed sparse graphs. You've got all sorts of stuff that for all sorts of scenarios. It's very useful. Now, again, you do not have to use Java for the last assignment. You can use Python if you prefer. If you use Python, you want to use NetworkX, which is an amazing graph library. Look at that. That's really cool. Look at that. That's pretty cool. It's a great graph library, but part of it. So this assignment is there are 2 graph assignments for a reason. Okay. The first is graph setup, and notice it's only worth 50 points. Can you not create dense graphs in Jung? Let's see, sparse graph, undirected sparse graph. Let's see what we get from abstract graph. I'm not sure where. I'm fairly sure you can get non-sparse graphs in there. But for the most part, a sparse graph is what you need. You don't need a dense graph. You only need a dense graph if more than 25% of the, if you get more than 25% of your all possible edges being used, and there are n squared possible edges. So it rarely makes sense to go for a graph. Let's see. It might be one of these functions, the delicate tree or the delicate forest. But Jung is fairly robust. But there's really no need to use a dense graph. In other words, which would use a matrix-based storage technique. But anyway, going back, did that answer your question, Michael? Do I know how to add weights to edges? Yes, I do know how to add weights to edges. Go to this PDF, and what you need to do is that you have to create your own edge class. Like this guy. Class myLink, which has a double capacity. He has a capacity and a weight, right? And an ID. The ID is the important part. That's what gives it the name. And then you can just give it a weight as well. So when you create and so now you can add something like this. Yeah. So there, and you're learning about the reason why I'm actually doing this. It's because a lot of times the game's turned up on this. Okay. A lot of times with graphs and when you're working in the industry or on more advanced projects, you don't want to reinvent the wheel. You want to take code that somebody else has used and improve it, which has a bit of that has a bit of cost associated with it in time, but it's often worth it to just learn how to use a library. And so that's why this part is worth 50 points and this part's worth 100 points. So this part over here is a really straightforward kind of assignment. The assignment itself is not the difficult part. It's mainly so that this is not the first. Look how short this is. Okay. Create a graph class to store nodes and edges, or download the graph library as a graph library such as Jung. Use it to implement breadth first search and depth first search. Follow the video from class if you need a reference. That's it. That's the extent of the assignment. Why? Because, as I mentioned, taking the time to write a graph class is a pain. I'm also going to point out that you probably don't want to grab a graph class from online, because every semester somebody does that, and they end up grabbing a tree, even though it says graph on it. It's a tree. And, yeah, I catch somebody every semester who does that. And it's just such a pain. It's so... do the work here, download Jung if you're using Java. Don't go to, like, Geeks for Geeks and download the thing there, because they'll give you a tree. Hey, Laser, are you tickling me? Don't tickle you. Oh, did you fall in? Ow. Oh. Oh, no. You okay? Let me pick you up, okay? No? What's wrong? Stay there? Okay. I tickled him and he fell down and bumped his back into a corner of a box. So, ow. All right. So, yeah, graphs. Just learn how to use Jung. It's not that hard. The tutorial is very easy. It's very straightforward. It gives you everything you need to create a class if you actually read the directions. And get a working solution. And then you can build depth first search and depth first search from there. The main point of having this assignment is so that the next assignment isn't going to be overwhelming. The next assignment, you aren't going to be trying to do it from scratch, which is password cracking. Right? I point out over here that these are the methods you need. Look at the methods, specifically get in edges or in degree is a big one that you're going to want to use for this one. This one's also a very short assignment. It just simply says, hey, go over to Project Euler. Solve problem 79 on Project Euler, which is a common security method, which is basically, I'm not going to go over it right now. It says essentially crack a password using these partial attempts to get a password. So it's this nice graph problem that's been dressed up like a security problem, and it's really cool. Hi. So yeah. And that's, again, the main reason we have this 50-point assignment is so that the 100-point assignment isn't overwhelming. We will do let's see, I do have a graph quiz. Let me see if it's actually if it's actually any good. But if so, I'll assign it. Remember, I did make a quiz available on sorting. So if you haven't done that, you should totally do it so that you'll get points, since it's auto-graded and stuff. All right. So that